So the first question says, when 5 grams of a fuel was burned, 150 kilojoules of energy is released. So 5 grams gives you 150 kilojoules. Okay, so calculate the energy in kilojoules that would be released if 60 grams of fuel was burned. Okay, so we don't know the one of 60 grams. Okay, so what we're basically going to do is to cross multiply, and we have 150 kilojoules times 5 times 60 grams divided by 5 grams. Okay, so grams will cancel grams, and these will go into this, giving you 12. So 150 kilojoules times 12, we have 1,800 kilojoules. Okay, so our option is C. Now, the 17th question is, which of the following is not involved in metallic bonding? So if we want to illustrate metallic bonding, we'd have something like this, okay, with positive ions, okay, and delocalized electrons freely moving everywhere, and they are being held together by electrostatic attraction. Okay, so we have positive ions, delocalized electrons, and electrostatic attraction in metallic bonding, but we don't have negative ions. Okay, so there's an option. And the next question says, 4 different metals were connected to silver in a cell. Okay, so this is the first electrode, and this is the other electrode. Okay, so the results obtained were recorded in the table. Okay, you can see the trends of metals from iron to zinc, and we can tell that magnesium is the one with the highest voltage. And then before the next highest is the unknown. And then the next highest is zinc. And then the least is iron. Okay. So which of the following could be metal X? Okay. So to figure this out from our data booklet, if we look at the booklet, so the trend is from magnesium, the unknown, zinc, and then iron. So from the page 10 of our data booklet, page 10, we will see the trend from here. Okay. From magnesium, and then aluminium, then zinc, and then iron. Okay, if you go down the electrochemical series trend, that is when you see silver down. Okay, so when we got magnesium, aluminium, zinc, and iron. So that is it. Magnesium. The second one would be aluminium. So our best probable option is aluminium. And then the number 19 says, which of the following is not a redox reaction? First of all, in redox reaction, the read and the dox represent reduction and oxidation. Okay, so that is to say, electrons is being lost and electrons are being gained in that simple reaction. Okay, so let's see which of them is the odd one out. Okay, now the first one, zinc. From the reactants, zinc is neutral, and then the product that's lost 2 electrons. That's why it's gaining a positive sign. Okay, then the hydrogen, it lost 1 electron in the reactant, but in the product it is neutral. So from reactant to product, it has gained. Why zinc from reactant to product, it has lost. Okay, so this is redox. While the second one, copper from reactant to product, it lost electron, while chlorine from reactant to product, it gained electron. So that is also redox. Option C, from reactant to product, bromine gained electron, while iron lost more electron. Okay, so that is also redox. But in option D, okay, barium is having a 2 plus, and in the product it's also having a 2 plus. There is neither a gain nor a loss of electron. Okay, and so our option is D. Now the number 20 says, which of the following would be recovered on change in an Ostwald process? Okay, the process of preparing nitric acid. Okay, so when they say recovered unchanged, it is likely talking about the catalyst in the process, which is not used. Catalysts are not being used in a reaction, so that will give us platinum